I am Dr. Ananta AMB, Professor and Head of Civil Engineering Department, Sai Vidya Institute of Technology, Bangalore. So today we will see one problem on butt joint. It is of design of steel structural elements. See here, two plates of size 180 mm and 180 mm by 20 mm are butt jointed using 20 mm bolts of grade 4.6. Two cover plates of each thickness 12 mm are used for the connection. 6 number of bolts are used for the connection on each side of the joint. Find the efficiency of the joint. See, the butt connection is given. Two plates are connected. This is the connection. So in the butt joint, we have to consider one side of the connection for the design. So the gauge distances, the edge distance is 30, gauge 60, 60, 30 it is given. Total width of the plate is 180 mm. Now the pitch is 60 mm, edge distance is 30 mm, it is given in the problem. See, these two are the cover plates. This is the main plates of having thickness 20 mm. Then cover plates are having thickness 12 mm, 12. These are the two cover plates. This is the main plates. See, no tie given. In butt joint, we have to design one side of the joint only. One side of the joint. Now we will see what is the data given in the problem. The nominal diameter of the bolt M20 bolt 20 mm it is given. Dia of the bolt hole is therefore 20. We have to add 2 mm extra for diameter of the bolt hole. It is 22 mm. See, up to 14 mm we have to add 1 mm extra. From 14 to 16 to 24 we have to add 2 mm, and above 24 we have to add 3 mm for getting the diameter of the bolt hole. For 4.6 grade bolts, FUB equal to 400 Newton per millimeter square. Ultimate tensile strength of the plate FU equal to 410 Newton per millimeter square. If it is not given also, we can assume this. The thickness of the plate T equal to minimum thickness 20 mm, because for cover plates we have to, two cover plates are there. Therefore thickness of the cover plate is 12 plus 12 is 24. Main plate is 20 mm. Therefore minimum is 20 mm is the thickness of the plates we have to consider in the design. Now there are three conditions. If a joint should be safe means the bolt should be safe, the main plate should be safe, and this cover plate should be safe. Therefore we have to calculate what is the strength of the joint by considering strength of the bolts. See, what is the strength of bolts or how much load these bolts can take, we have to calculate. See, it is not, for that case, that is the first case A, the strength of the joint by considering strength of the bolts. In that we have to calculate the bolt value. Bolt value is the minimum of shear strength of the bolts and bearing strength of the bolts. Therefore first we will calculate shear strength of the bolts. See, from page 75 of IS 800 we are having VDSB equal to FUB by root 3 into gamma MB into NN into ANB plus NS into ASB. For the butt joint, both NN and NSS are 1, NS is 1. See here, FUB is given in the problem 400 Newton per millimeter square. Gamma MB is 1.25. NN is 1, where it is the section where root thread is considered. This is the section where root thread is not considered, that is NS. NN equal to 1, NS equal to 1. Net area at the root thread is 0.78 times the nominal area of the nominal diameter of the bolt. Therefore 0.78 into pi into 20 square by 4, it is 245 millimeter square. Then NS equal to 1. ASB equals pi into 20 square by 4, it comes 314 millimeter square. From this we can calculate what is the value of shear strength of the bolt. 400 divided by root 3 into 1.25 into 1 into net area AN is 245 plus 1 into 314 millimeter square. From this we got the total strength, shear strength is 103310 Newton. If you convert this divided by 1000 into divided by 1000 to get in kilonewton, it is 103.31 kilonewton. Now we will calculate what is the bearing strength of the bolt, because bolt value is minimum of bearing and shear strength. Bearing strength of the bolt, it is also from page 75 we have VDPB equals 2.5 kb into D into T into FU divided by gamma MB. The kb is the minimum of following. Kb is the minimum of following. These values minimum of following. One is E by 3D naught. E means edge distance 30 mm we have. D naught means diameter of the bolt hole 3 into 22. We are getting 0.45. Second is P by 3 D naught minus 0.25. 60 by 3 into 22 minus 0.2, we got 0.0659. Now, third one is FUB by FU. Strength of bolt divided by strength of plate. 400 by 410, we get 0.9756. Last one is 1. It should not be more than 1. Therefore, KB value is 0.45. From this we calculated what is the VDPB value. 2.5 into KB is 0.45. Diameter of the bolt D is 20 mm. Thickness, minimum thickness of the plate is 20 mm. 20. FU is 410 for the plates divided by 1.25. We got 149076 Newton or 149.076 kilonewton. Therefore, we have to calculate the bolt value. Bolt value is the minimum of bearing strength and minimum of above two values. That is minimum of shear strength of the bolt and bearing strength of the bolt. We got it is 103.31 kilonewton. Therefore, strength of the joint by considering strength of the bolt equals number of the bolts on one side of the butt joint into bolt value. There are 6 bolts are there. Therefore, 6 into 103.31. It is strength of the total strength of the bolt is 119.835 kilonewton. Now, B is we have to calculate what is the strength of the plate also. Strength of the plates also. Therefore, strength of the joint by considering strength of the main plate. Strength of the joint by considering strength of the main plate. Strength of main plate. Strength of the joint by considering strength of the main plate. Now we will see this. What is the strength of the joint by considering strength of the main plate? See here. See, strength of the joint by considering strength of the main plate. See here in the butt joint. See, extreme outside line of bolt is critical section for main plate. Therefore, this is section 11. This is section 22. We have to calculate what is the strength of the joint at section 11. It is we have to calculate strength of the main plate at section 11 and section 22. Minimum from this value is strength of the joint by considering strength of the main plate. Now here first we will calculate the strength of the main plate along 1. There are 3 bolts. We have to drive 3 bolt holes. Therefore, net area becomes this much less, this much. 3 holes are there. Therefore, we are having from page 32 of IS 800 formula is TDN equals 0.9 into AN into FU by gamma M1. Net area at 1 is total width is 30 plus 60 plus 60 plus 30 means 180. 180 minus 1 diameter of hole minus 1 diameter of the hole, 1 diameter of the hole into thickness will be the reduction area. Therefore, it comes 180 minus 3 into 22 into 20. We are getting this much is the area. Therefore, we can calculate TDN, strength of tensile strength of the main plate. TDN equals 0.9 into AN is 2280 into FU is 410 for the place divided by 1.25. We got 673.06 kilonewton. Next, now we will calculate what is the strength of the plate along section 22. Here also 3 bolts are there. Net area is same. TDN equals 0.9 AN into FU by gamma n plus number of bolts in the previous lines. Here 3 bolts are there into bolt value. Therefore, 3 into number of bolts in the previous lines into bolt value. We have to add the bolt value of that. Therefore, TDN is 0.9 into 180 minus 3 into 22 into 20 into FU is 410 by 125 because here also there are 3 bolts plus 3 bolts are there in the previous line into bolt value is 103.3 already we seen. Therefore, the strength of the plate in section 22 is 982.98 kilonewton. Therefore, the strength of the joint by considering strength of the main plate is minimum from these two values. Therefore, 673.06 kilonewton. Now, also third case we have to calculate strength of the joint by considering strength of the cover plates. Strength of the joint by considering strength of cover plates. You see here these are the two cover plates are there. For cover plates, inner side of the bolts is the critical section. We calculate what is the strength of the cover plates at this section 1. Here thickness of the cover plate, 2 cover plates are there. Therefore, 12 into 12, 24 mm. Again the equation is same. TDN is 0.9 AN by into FU by gamma M1. Therefore net area here also same, cover plates also we are driving the 3 bolt holes. Therefore 180 minus 3 into 22 into 24, it is 2736 millimeter square. Therefore TDN equals 0.9 into this 2736 into FU is same for plates 410 divided by 1.25. We are getting this is 807,667.2 Newton or 807.67 kilonewton because we are dividing by this 1000. Therefore strength of the plate by considering strength of cover plate is 806.67 kilonewton. Therefore the strength of the joint is minimum of above A, B and C. It comes 619.835 kilonewton. Now we have to calculate what is the efficiency of the joint. See, efficiency of the joint eta equals strength of the joint divided by strength of solid plate into 100. This is the strength of the joint already we got. We have to calculate what is strength of the solid plate. Strength of the solid plate equals Fy by gamma m0 into Ag. See, Fy, the yield strength of plates for rolled steel section is always 250 Newton per millimeter square. Gamma m0 is 1.1. For yield stress it is 1.1. Area Ag is gross area of the main plate. It is 180 into 20. We got the solid strength of the plate is 8181.8 Newton or 818.18 kilonewton. Now, so efficiency equals strength of the joint 619.835 divided by the strength of solid plate into 100. It comes 75.75%.